Okay. As she introduced, I'm Rajesh Tool. I work with PitneyHarris, and today I'm here to talk about how we leverage FME functionalities and capabilities to rebuild and revitalize a data product called as StreetPro Australia. So before we delve into those details, let's quickly have a glance how we are going to progress with our presentation today. So first, we'll have a very brief introduction about PitneyHarris and StreetPro Australia. Then we'll discuss why revamping of data product and production processes was required, what were the problems, and what were the challenges. And then we'll discuss what was the solution that was developed by us. And we'll discuss some of the production processes that we built as part of this project. And we'll discuss those processes at a very high level. And because of time constraint, we'll not be able to discuss those in detail. But if you're interested in knowing more, I'm happy to have that discussion after the session. And please save your questions for the end. So PitneyHarris is a global technology company which offers innovative products, solutions, and services that empower commerce. And we have been empowering commerce in 5 key areas of competency. These are identify, locate, communicate, ship, and pay. Identify and locate forms our location intelligence portfolio. In location intelligence suite of products, we have MapInfo Professional as desktop mapping application and MapInfo Discover as natural resource management application. We have Spectrum Spatial Analyst and MapExtreme as WebGIS application. And we have Confirm as asset management application. And we have AnySite Australia for applied analytics. For geo-enrichment, we have Enterprise Geocoding and Spectrum Location Intelligence module. And for Australia, we have GNAP Premium. And we also have Enterprise Routing module. And I'm a certified FME professional. I work in data engineering department, where we build data products that cater to the requirement of LI portfolio. StreetPro Australia is a vector data product. It comprises of streets, point of interest, land use, land cover, and other additional layers. And it is available in 3 flavors. StreetPro Navigation is the most detailed and comprehensive version of the product. It contains routing information, and this routing information includes node link relationship, one-ways, and turn restrictions. And most of our customers use this product for their route network planning and logistic needs. StreetPro Classic is a less detailed product as it is missing the routing information. And StreetPro Display is the least detailed product, and it is mostly suitable for display purposes as it supports faster data rendering. Traditionally, the streets that were included in StreetPro Australia were based on data that is adopted from PSMA. And PSMA is a public sector mapping agency, and it is owned by state and federal government. So we adopted PSMA data as a base back in 2001, and we incrementally added data on that base each quarter based on customer feedback and field surveys that we carried out from time to time in different cities. In late 2014, we received some feedback from our key customers, and when we started investigating that feedback, we discovered that there was a huge gap between PSMA data and the streets version of PitneyHarris. And in some areas, this gap was huge. And when we did further investigation, we discovered that the quality of PSMA streets has improved vastly over the last few years. And when we did a further investigation, we discovered that the processes that we were using earlier to identify changes between 2 versions of PSMA data were missing those updates in most of the areas. And in some areas, it was picking up those changes, but because of the old and manual capture processes, we were not able to apply those changes to our version of the streets. And this led to a huge backlog. And this backlog was increasing each quarter with new updates coming. So when we were looking at this problem, we did a comparative analysis between PSMA data and PitneyHarris version of the streets. And we found some interesting facts, interesting differences between these two data sets. So we discovered that the quality of PSMA street has improved vastly, but it was mostly in terms of geometry and mostly in terms of positional accuracy of the streets. And it still lacked the key information that was required by us to build a good routing product and a good geocoding product. And that information was still available and was very good in the PitneyHarris version of the streets. So we wanted to preserve the value add that we captured over the last 15 years, and we wanted to build a solution that can take best from both the data sets, merge those two data sets, and create a new hybrid version of the streets that is better than both the input data sets. And at the same time, we wanted to improve our production processes. We want to build processes which are capable of comparing two versions of PSMA data in a much faster and efficient way and give us those changes very quickly. And we also wanted to integrate those changes. We also wanted to apply those changes to our database streets in a much faster and efficient way so that we can provide quarterly updates to our customers. So all these challenges, these requirements led to creation of project Cold Fusion. And the project Cold Fusion is executed in two phases. In phase one, our focus was to build processes that can merge these two data sets, create a hybrid product, and then we enhance the value of that product, improve the topology, improve the attribute accuracy, and then maintain that database, that version of the streets as a baseline for all the future updates, all the future value add on that version of the streets. And in phase two, we wanted to build the processes that can identify updates in the new version and apply those updates automatically or in some automatic way. And we wanted to build processes in phase two that are repetitive processes, can be used anytime, and we can run them anytime, derive the results, apply those results to database, and get our database up to the latest vintage. So, as I mentioned, in phase one, the focus was to merge these two datasets and maintain it in an Oracle database so that we can value add for future updates. And at the same time, based on roadmap from our product management, we wanted to change the data model. And we wanted to apply new specifications to our streets so that we can support added functionality that was required by our customers. And we also wanted to introduce persistent and unique IDs in our streets. And we also wanted to provide quarterly updates. And those quarterly updates should have incremental updates and change log history, what has changed between two dates. And in phase one, we built about 22 different processes. So today, I'll not be able to go through all of the processes, but I'll discuss some of the interesting and some of the very basic processes that we built. So this is the first process that we built. So this process is called as PSMA street conversion process. So the PSMA data that is provided by PSMA is in relational model. There are about 79 different tables for 9 states and territories, and that passes through this process. And in the end, it creates just one table for each state. And during this process, we manipulate that data. We add new features, we add new attributes, and we do a value add on that data. We check for issues in the data. We correct those issues automatically wherever possible. And within this process, we have built many custom transformers. So one such transformer is a road type. So road type is basically classification of road features based on their functionalities. So a road type value for a freeway segment would be different to a road type for a track or a primary road. And road type classification also varies between features within the same class. For example, the roundabouts would have a different road type value as compared to a ramp feature. This is another custom transformer that we have used in this process. This transformer plays with the ramps. So in this process, we assign exit numbers and on and non-ref values to these ramp features. And we also play with the street names and alias names for these ramps. And we follow a different street type abbreviation in PitneyHarris as compared to PSMA. Another custom transformer that we build is for styling. So in this transformer, we are assigning styles to all the streets based on road type and MI code. So this is done basically to improve the aesthetic values of the data. This is another custom transformer within the same process. And here in this process, we are generating nodes. So we generate nodes for all the start and end node, and also for the midpoints. And we assign persistent IDs. This is a point data set. It is then automatically saved into Oracle database. And later on, we build relationship between those nodes and these line segments. A node link relationship is built. And so that this helps us to improve the routability of our streets. This is a new process that we built in phase 1 called as auto roundabout capture process. So during comparative analysis of PSMA and PitneyHarris streets, we discovered that the roundabout features in PitneyHarris streets were huge. And there were many states, some states where PSMA data does not have any roundabout features. So we wanted to preserve the roundabouts that we have captured over a period of time. So we wanted to take those roundabouts from old version of PitneyHarris streets and apply them automatically into the new streets. And at the same time, we wanted to preserve whatever roundabouts that are available in PSMA data, because the position geometry was much better in PSMA data. And these roundabout features that are available in PSMA data, they have a problem with their line direction. We could not rely on the line direction because they have this data is not developed by them to meet the routing capabilities. So in this process, we manipulate that line direction, and we rearrange the direction so that this line direction gives us the flow of the traffic. And we assign one-way values, and we change the specification at this process. And similarly, we built many processes where we derived or captured automatically data from our value-added streets. Like we build a process to capture divided roads or dual carriageways automatically, play with the one-way values, and correct the line direction. So here you can see on your left side is the input PSMA source data, and on your right side is the output that came out of this phase 1. So here you can see there are a bunch of streets that were missing in the input data, but they were available in PitneyHarris streets. They were captured automatically. And we have played with the dual carriageway divided roads there, corrected line direction automatically, and also captured the roundabouts, construction lines in between, and corrected the direction so that traffic can flow smoothly and it can be used for navigation purposes. Another very interesting process that we built during phase 1 is the auto-addressing processes. So at this stage, these streets do not have any address range information, but we want street range information in our streets so that we can support geocoding requirements. So in Australia, we have a product called as GNF Premium. It contains about 16 million rooftop addresses. So we use this product and build a relationship between these address points and line direction and automatically capture address ranges on the streets. So to do that, we needed to have a correct one-way information, correct line direction on the streets. So we corrected it in previous stages. And we needed to look at the address point data set, and we have to identify what is the street value, whether it is odd or even, and whether all the odd addresses are on one side and even addresses on the another side, or they are mixed or they are irregular. So we built this process that takes all those parameters into consideration, builds that relationship between these points and line, and in the end, it comes up with this information. This is the line direction, this is the maximum number on left side, this is the minimum number, this is the numbers on the right side, and then it assigns those address information to the street segment. And while doing that, it also identifies the pattern, whether the pattern followed is all the odd numbers on one side, all the even numbers on another side, or it is a mixed pattern. And we also assign the address source so that later on, whenever we are doing any update to these street segments, we know from where these address ranges are coming and what is the reliability of these address sources. This is the auto-addressing process that is working under the hood and doing all that relationship building and assign those addresses. So the data that we have at phase 1 is now superior to both the input sources and is maintained as baseline in Oracle database, and all the future enhancements, all the future updates are done on that. So now we start with the phase 2. In phase 2, as I mentioned earlier, we wanted to build the processes that are capable of identifying changes between two versions of PSMS source in a faster and efficient way, and also they should be capable of doing it automatically without any manual intervention. So when we start with this, we take two versions of PSMA data, we do a street conversion on that data, we convert PSMA data into our specification, and we run a process called as CHAD, change detection. So this process creates delta change logs so that we don't have to deal with the complete data set. So this change detection process, please. So this change detection process takes two versions of PSMA data, identifies, okay, what has been deleted between two versions, what has been inserted, what is updated, and it also considers, okay, if update is done, whether it is geometry only update or it is a geometry and attribute update. And if it is geometry and attribute update, what are the attributes that updated? Whether street name has changed or a road type has changed, whether the street is no more routable. So it creates all that information. And later on, we pass that information to our next process called as FRED. So FRED is our final result evaluation against the database streets. So these database streets are the baseline streets that we created at the end of phase 1. So in this process, we have business rules, and we have built test cases so that process itself can take decision. So like these changes are identified by the previous process. This process looks for those changes in the database streets because there is a chance we might have also done a similar change. So if an update is coming from PSMA, it checks whether that update is already been applied by us. And if it has been applied, then based on the rule, it will take a call whether I have to update something else in the history table or the change logs, or I have to ignore it completely. And if that update is not applied, then it decides, okay, whether I can do that update automatically, or so while this process is deciding that this update can be done automatically, it checks whether this update is going to break the integrity of the streets, whether it is going to cause any topological issues, whether it is going to break any constraints, whether it will have any effect on the triggers. So it carries out all those calculations based on the rules that we have defined within the process. And if it is not causing any issues at all, then it is moved into a auto bucket. And if it detects that there is a potential of an issue if it is done automatically, it is moved into a manual bucket where it is reviewed manually by a team member. So all these changes that all those changes that are moved into auto bucket, they are now then passed on to another process called as Dave. Dave is our little guy called as data and attribute validation engine. So here we have, based on business rule, based on product specification, and based on our attribute accuracy requirement. So we have built all those test cases here, and then this data is passed through this process, and this process checks the overall quality of that data. And if this process identified any issues, then they are flagged for a review, and if there are no issues identified, they are moved on to the next process. So if any of street segments are marked for a review, it is reviewed by a team member, and then flag is updated, and then they pass on to a next process called as database update. So we use this process to take all the records that has been passed through Dave are in auto bucket, and they are applied automatically to the database streets. And at the end of this, we'll have new versions of the streets that is updated automatically based on the changes that we have received from our vendor. And in Oracle, we maintain this database in Oracle, and in Oracle we have enforced constraints and triggers. So we try to control bad data from entering into the database. And we have triggers to apply certain changes automatically. So there may be a case where we want to derive one particular attribute based on number of another attributes that are coming as an update. So that is updated. And we also update the change history, and we record all the changes so that if we have to track back, we can do it very easily at database level. And from time to time, our teams go into field. We do a field capture, and we access this database from our locations in Brisbane and Noida, India. And we do updates on this live database by accessing this database in MapInfo Professional. And this database is continuously updated based on customer feedback and other field works that we keep on doing. So what we achieved as an end of the project called Fusion. So because of the new processes and because of inbuilt quality control, we were able to improve the content and quality of the overall data. And this helped us to maintain data. The processes that we built in phase 2 help us to maintain data in a much more efficient way and apply those updates in an automatic or semi-automatic way. And because these processes are automatic, we are able to apply these updates more frequently as and when we are receiving it from our vendors. And because some of these functionalities were required by some of our key customers, so we listened to them and we delivered them what they wanted. So in the end, we make them happy. And this is a screenshot from StreetPro Navigation, the final product. So what's next for us? We did this all at automation completely with FME Desktop. Last year, we started experimenting with FME Server. And now we have FME Server running in distributed environment. We have FME Server core in Brisbane, and we have engines running in 2 different geographies. One is in Noida, India, and Henley in UK. So, and we have started migrating our processes onto FME Server. So now we want to further automate these processes so that we can trigger those updates based on events as and when they are happening. And later on, we want to move this, the output, and want to provide this output to another initiative at PitneyHarris called as Commerce Cloud, so that we can provide real-time updates and notifications to our key customers, so they can download data and view data and use it in a much more frequent way. This brings us to the end, and happy to take questions.
Oh, question one.
The conflation has always been a perpetual kind of difficult task, and human intervention, is always inevitable. I was wondering, in your case, mostly talking about automated flow, and what percentage of, you have a team of people reviewing those and making some of the rule decisions on the fly rather than automated. So could you tell us how you guys pull this off? That's question number one. The other things regarding the change detection, I think there's also possibly you could use Oracle's essentially do a SQL to do the change detection. Have you guys looked into the two approaches, transformer versus the SQL approach, to identify changes? Thanks.
Yeah, both of these questions are good questions. The question number one, where you want to know what is the percentage that we are able to do automatically and what is the manual percentage. So each quarter, the updates that we are getting, in some states, we are able to get 90% of the data into our database without any issues. And there are only 10% cases where manual review is required. And in some states, it's about 70 to 80% automatic and 20 to 30% manual. And this variation is more. Say, for example, if we have done a lot of updates in one particular state, and those updates are also coming from PSMA data, then in those cases, those areas will have that percentage varying. There would be a lot more into manual review, because based on our rules, we have categorized our rules that if we have also done the changes, so we want to give those changes more priority, because we want to trust those changes more. And we do not want to update those changes. We don't want to lose the value add that we have done. So we flag them for manual review, so that percentage increases. Coming to the second question, in Oracle, change detection can be done, but the doing spatial operations in Oracle is very slow. We try to do that, but you cannot beat what you can do with FME. FME is much better, and it's not a very simple change detection that we are doing here. So in change detection process, we are not only finding simple delete, inserts, and updates. So once updates are identified, take an example. If update is identified, we want to have further categorization, what type of update it is. And we divide whether it is geometry only update or it is a geometry and attribute update. And if it is a geometry and attribute update, then we divide it further. Okay, what type of attribute it is update? Whether that attribute update is significant or not. So for example, in New South Wales, the route numbers, so now they changed their route numbering system. We have only alphanumeric route numbers in New South Wales. But from PSMA, from time to time, we get non-numeric route numbers. So we want to ignore them completely. So we have to identify those changes. Okay, this change is done, but it is not valid for us. So it is a noise, leave it there.
Could you go into some more detail about how you're doing the any geometric, or are you doing any geometric conflation, or is it all just based on where you found the PSMA data has better accuracy, or complexity to what the PitneyHarris database?
Yeah. So in our initial investigation that we carried out in 2 states, we found that the positional accuracy of PSMA data was much better, and they were positionally more accurate. So we adopted that geometry as a base to work with, but there were certain areas where the geometry that is coming from PSMA, from PitneyHarris old version streets was much better. So for example, roundabouts. So roundabouts in our data were much more better. So we built processes that can capture those roundabouts automatically. So to to identify those changes based on geometry, we use special buffers. So we create special buffers on streets. So like, and maybe I'll show you later on my system. So like these are like if like it's a dual carriageway, we buffer it in a way that those two buffers are not interacting with each other. They are nice and clean individual buffers, not overlapping, and at the intersections they are like pencil edges. So we create those buffers. We do a spatial comparison on that first, and this is done in multiple phases. So first we do a very simple line and poly overlay operation, and we ignore the segments that are not completely within. Whatever is remaining then passed on to second phase. Then we chop that geometry from both the ends and then see whether it is lying. Now it is lying or not. And if it is lying, then it is considered. And then we run a third phase also where we chop it further. And then we also have another test case where we create midpoints and we see whether that midpoint is, okay, ends are there where midpoint is lying. So all those, these are complex calculation. We have built rules, and these rules also varies from state to state because the contributors in PSMA data, they are like many local government agencies, LGAs that submit this data, and a lot of people are doing it. Their editing way is different, and in some cases, for a simple line geometry, there would be just 2 nodes or 3 nodes, so positional accuracy would not be correct. In some cases, it would be node every few very dense nodes. So that's why like we have to come up with rules for each individual states.
I got one more.
Okay, go for it.
Thanks. So considering that some of the PSMA data is probably used for 911, or I guess whatever 911 is in Australia, like emergency services, do you ever consider, does any of your data ever go, if you find really bad issues that you've gotten from the state, if you correct that, does any of that ever flow back to PSMA, or is it just pretty much a one-way relationship?
So now we have a very good relationship with PSMA. So we provide them feedback, and they make changes sometimes. But again, they are not the creator of the data. They pass on that feedback to the authorities that are submitting the data, and sometimes like it is not a fast turnaround, so it takes a lot of time. And in Australia, emergency services use products that are built by PitneyHarris. Yeah, and some of the changes that we have done in this remodeling of these streets is also based on feedback that we have received from them.
Thank you so much.
Thank you.